Hi there! Today, we're diving into a coding problem that might sound fancy at first, but is actually super approachable, the palindrome number. This is a popular problem you often see in coding interviews at top companies like Google, Amazon, and Meta. But don't worry, it's much easier than you might think. By the end of this video, you'll have this down pat and you'll be ready to impress in any interview. Let's jump in and break it down together. So, what exactly is the palindrome number problem? Imagine you're given a number, and your job is to figure out if it reads the same backward as it does forward. If it does, then congratulations, it is a palindrome. Think of it like reading a word madam in both directions. It looks the same, right? But here, we're working with numbers instead of words. Now, where can you use this in real life? Picture a ticket validation system that identifies lucky numbers like a concert or raffle ticket. If the number is the same forward and backward, it gets flagged as special. That's where palindrome checks come in handy. With that in mind, let's explore some approaches to solve this. Approach 1. Reversing the number, the flip it method. The simplest way is to reverse the number and see if it matches the original. Imagine looking at your phone number displayed on a screen in reverse. If it reads the same, you've got a palindrome on your hands. Here's how we can code this in JavaScript. In line 1, we define a function called isPalindrome that takes in a number x. In line 3, if x is negative, we return false right away since negative numbers aren't palindromes. In line 6 to 7, we set up num as the input number and reverse as 0 to hold the reversed number. In line 10, we start a loop that continues until num becomes 0. In line 12, we extract the last digit of num. In line 14, we add this digit to the reversed number by multiplying the current reverse by 10 and adding the digit. In line 16, we remove the last digit from num by dividing it by 10. In line 20, finally, we check if the reversed number matches the original. Now, what's the time and space complexity of this? The time complexity is O of log base 10 of n. The time depends on the number of digits in the number, because each step removes one digit. If the number has 5 digits, it takes 5 steps. This is why it's logarithmic. The time grows with the number of digits, not the value of the number. The space complexity is O of 1. We're only using a few variables, num, reverse, and reminder, so it's very memory efficient. Approach 2. Reversing half of the number, the efficient flip. This approach is even smarter. Instead of reversing the whole number, we just reverse half and compare it to the other half. This is a great way to avoid issues with large numbers. Think of it like folding a piece of paper in half and seeing if both sides match. You only need to check half to know if it's symmetrical. In line 1, we define the function isPalindrome. In line 3, we check for negative numbers or numbers ending in 0. They can't be palindromes unless they are 0. In line 6, we set up reverse to hold the half reversed number. In line 9, we use a loop to reverse only the second half of x. In line 11, we build the reversed half by taking the last digit of x. In line 13, we remove the last digit from x. In line 17, we compare the reversed half with the original half to determine if they match. Now, what's the time and space complexity of this? The time complexity is also O of log base 10 of n. Like the first approach, this depends on the number of digits in the number. By reversing only half the digits, we reduce the steps, but it still scales logarithmically because each digit takes a step. The space complexity is also O of 1. We're using minimal space with only a few variables, keeping memory usage very low. So, there you have it. We went over 2 straightforward ways to figure out if a number is a palindrome. These techniques are incredibly useful, not just in coding interviews, but in real-world software development too. Whether it is validating data, checking symmetrical patterns, or building algorithms that recognize sequences, palindrome checks play an important role. Thanks for watching! If you enjoyed this video, please like, subscribe, and drop any questions you have in the comments below. Keep practicing and happy coding!